connecting. Let's see, 1 minute. I'm right about to start and see how it works, but now it's set it up for the 1 minute. 1 minute of the delay. Let's see if the YouTube will work. And I don't know what to tell you. Just a bunch of thoughts. Let's see what is going on. So I discarded delay. It means, I think, that I removed all of the recorded data before sending them, but we will see. Low latency for the YouTube. Does it mean anything? I don't know. Wait just 1 minute to see that everything goes fine and I can see something on a YouTube. But I think I set the proper parameters there. I already see the promotion in the chat. Yeah, thank you very much for the promotion, blah blah blah, lower price. Thanks very much. Okay, and okay, right about to start. Okay, I see the stream is running. Okay, it's fine. Okay, I see myself. So let me a bit prepare the desktop. It's bothering me still there. Okay. Thanks everybody. Ivan is here, and this channel name is Ivan Byte TV, and the same name Ivan Byte TV on Twitch and on YouTube. You can find this channel with the videos and streams. And for today I want to record this video just for the 1 hour to show how I'm working with the Neovim, with Rust, and what I'm developing, and yeah, just show my work. And I am pretty open for any questions you can ask in the chat for anything. And yeah, I'm going to set a timer, so I set a timer. I'm going to share the screen and start working. Okay. So, and for today's stream, I want to work a bit on my library for Rust. And now you can see my new shell terminal on Windows. It's pretty nice terminal. For example, yeah, let me switch to my directory. For example, if you do the ls, it shows the formatted output. I like how it looks like. Yeah, it's pretty neat, right? It looks awesome, I would say. I don't know, should I make it a bit larger? I mean the font, but to me it's pretty visible. So yeah, I don't know. Should I or shouldn't? Sorry for these things with the mails, but fine. Okay, and now I want to work out on this library. And this library you can find here, nothing here. In the crates.io, serde-flow. I was thinking about this library for quite a while, but I faced with the problem when you want to serialize the data. So you have the struct. I will make it bigger. So when you have a struct, this one, the user, and inside of the struct you have a couple of fields, but previously the first version of your struct, it was something like that. So only one field that contains probably your first and last name, but you decided that you want to have it differently. You want to have the first name, middle name, last name. So we want to have 3 fields. And if you already serialize that and store this part on your disk, or you're using that for the communication between the I don't know, server and client, if you implemented the binary protocol, it's not very convenient to use normal serialization, because sometimes, for example, if you serialized this type of object and you're trying to deserialize this type of object, it will skip the last name, and it will and the deserialization will read the last name like a middle name, because there's two fields, they goes in order, and this is causing a lot of problems. And that's why I decided to implement my own library that will help you to migrate from one version to another. It's similar to Liquid Base for the Java development and databases, when you have kind of a migration script. So basically you use this annotation, and you need also derived annotation flow. You specify the variant, and you specify some additional parameters, but most important is this, the variant. And you can have a variant 2 and variant 1. This was the first variant of the user. When you're developing your application, you just create one more, and etc. And then for all of them, for this variant 3, the third variant, the last one, you can specify that previous variants were user v1 and v2. Make sense? Makes sense. So here you specify, you keep this struct in your code base. Yes, you need to keep it. And here you can specify the variant 2 and variant 1. And moreover, you need to specify a couple of traits from. So you need to create the user, this your last user, from user 1 and user 2. That's pretty much simple. And how it works, it tries to read the struct and define the type. So it sees the variants, variant 1 or variant 2, and then decode them, calls the method from, and then here we go, it converts it to this format. It's pretty much simple. You created the user v2, just the John Adam Doe, for example, and then you save it to the path, and this is the old user, but you want to read this like a new user, so you use user load from path, you specify the encoder and decoded this path. Pretty much simple. And what I want to work out on this library, let's go inside of this. Here we go. Maybe I need to, yeah, okay, I'll change the size like this. So we have the couple of sources that I'm working on, and my main reason to work, I want to work on increase the one more size, maybe change a bit like that. So here I have a couple of, it contains the serde-flow derive, and the test suits. So I implemented a couple of things for the encoder, and one of them is zero copy. Zero copy, if you know, you can use the archive library, and I think it's a short name for the archive. And with the archive library, you can deserialize, you can do the zero deserialization, and it works pretty much smoothly. Let me scroll down, I will show you the code. So here I have a couple of things, like I have a reader, and the reader contains some bytes and some archived things that helps you to read it. And mostly I use this archived part like a cache, so you don't need to do that multiple times. Let me scroll so you can see this archive, and here we go. You borrowed some archived variables, then you verify that. So if you remember, there's a ref cell, and inside of the ref cell I'm storing it. So if it's already present there, I don't need to do the deserialization one more time, it's already there. And here we go. And if it's not there, I need to destroy this borrow and then deserialize that. So I need to use the zero copy deserialization straight from these bytes. I mean from these bytes. So it happens just right from them. And then I replace them here. Pretty much simple, and return them. Again, borrow and return them. Pretty much simple, and you can use this archive. That's it. Then I've been working on the memory map deserialization. That's what I want to work a bit today. But yeah, we will see how it works. And again, if we check the tests, there copy basics, here we go. Not the problem. Okay, I have a mem map. I don't need to have a mem map here, right? So yeah, I don't need it. I can remove it. So what I can do something like that. Nice, removed, and I don't need this. Can use the normal map. Here we go. I need to read it, right? Oh, it's a normal map. No, I still do need it. What is in Hunk? So in Hunk, the old one. Okay, so it works. Here we go. Let's try test it. Okay, what is the problem there? Problem with the archive. 0 arguments. You need to provide the type. Why? It was working fine a couple of days ago. Not days, but it was working yesterday. That's a part of the deserialization. Ah, yeah, that's a normal archive. Yeah, okay, I got it. So I don't need to do that. I can just archive. Right. Let's go there. To find them one more time. Okay, I don't need to use this. It should be like that. So archived user. Okay. To copy that. Okay, here we go. So paste the user archive here, right? Go. What I'm doing. Okay, now we can test it one more time. One more error. Oh, we don't have a JSON deserializer. Ah, yes, I created the... Also, it works with the JSON, but I need for that a basic migration. Here we go. I think I need a simple implementation for that to run it properly. I don't want to use... I think that's pretty extensive with the users. I want to use something with the cars. For example, here I have the implementation with the cars. So I have car 1, car 2, and that less fields and less work to migrate, because I use, for some of them, I use the price like a number, then I convert the number in a string in the last version. So I'm going to copy that and copy probably this part. Okay, this did. Okay, now blocking. It doesn't matter for me. It doesn't matter for me at all. I can move in JSON back here. So couple of variants. Do I need to have format? No, I don't need to have this part. I can remove it, save it. Do I need a bin code? No, I don't need a bin code. Completely saved. Flow is here. Migrate, normal migration. Post, and yeah, here I can implement the car. Let's say it's a car V2, right? What is in the V2? Just a one name. Wait a minute. The basic migration. I'm doing that in the wrong file, right? Yeah, I need a JSON. This part's okay. I don't need a user. I want to use the car lead. Well, okay. What's the name of the car? I don't know, BMW. It's fine. I need to convert to string. Model, I don't know, X5. And the price, I don't know the actual price for that. Let's say the 75,000 of something. And I want to change it to user v2 brand. Yeah, the brand. Okay, the brand model. It need implement the user. User test v3. What is user test v3? Just the full user, right? Just the full user. What was here? It was what migrate. Okay, so I converted in the last 4 months, so I need to get the error here, right? Right. Let's try to create this error. And I think somewhere I implemented this test struct. No, I didn't. Again, users. Maybe is async migration test car test. Let's copy that. Okay. JSON migration there. Why did I change that? Over here, somewhere here. Car2. Okay. Okay. Must be an error. Why? Okay, non-blocking. I don't want to have a non-blocking. Is again non-blocking? Yes. Okay, it's just a file, not a non-blocking. Now I need to change the user to the car. Let's change it to the brand name. Name and price. Only name and price. Okay. Price. Just that. I said it's 75, right? Of what? Okay. 75. Like that. So BMW X5. To the user, and I'm loading a car. No name, yeah. What is the name? Okay. Then I should normally, now I have the error to convert it, and then I should have a normal operation, right? Okay, so loaded car. I loaded car. Then this part, it's car test. Okay. Define it multiple times. Really? Where the car test? More time. No. Okay, I see. No, I don't need it. I don't need it, please. Here we go. Let's run a test. Oh yeah, BMW, BWM, BMW. Now it works perfectly. Now it works. I want to show you the one more. So I have some bench tests, and then a bench test I'm comparing. Oh, it doesn't work now. Okay, I will fix it. I will fix it now, and then I'll try to calculate what I can do. I need to remove it. I need just the flow. That was an old version of the system. That was how I was considering to work on it. So this file, I just need to have a flow, not even file. Just the flow is more than enough. The copy is not present here. What I need to implement, a flow, and the variant is this. And I want to store it in the file. I want to have it 0 copy. Now I specified everything inside of the flow attribute. Then it's fine. And here also. So what I'm doing here, I have an object in serde. This object contains field 1, field 2, and contains the hash map. And the same object for and by the way, yeah, it contains the object serde, and this object serde contains struct which in its part contains the field and the two numbers. And the same, and exactly the same for zero deserialization. We have, you have object top archive. Here we go, the same parameters. And I have the two functions, and both of them creates a 2000 objects inside of the hash map to see how it works with loading the large object. And it contains the string and a couple of numbers. That's pretty much it. And here we go, what I'm testing. I'm testing what is faster, to use the zero copy deserialization with the archive. You can see here, so this is a normal serde file, and the serde for the deserializing I use the vscode deserializer, and for the archive deserialization I use the built-in archive library, the technology for deserializing. So here I also need to load from path. I'm loading from path. Does it contain any other errors? No, it seems fine. In my mind, it became much simpler when I have a variant, a file, and when I have this attribute, because it's pretty much clear how it works. So let's test them. Compiling. Still no one here, but it's fine. I think my YouTube channel doesn't have a huge audience, so I'm pretty much fine. Maybe I can create some shorts from my life, and then we can do something with the shorts. But yeah, of course, I'm not doing something for improving. No, I'm doing a lot of things to improve the quality of my streams and trying to find interesting themes. Not the streams, it's the first stream officially about the programming. But in general, I'm trying to improve the quality of the videos and record the interesting information, and etc, etc, etc. Now you can see that the vscode deserialization, it took this amount of time, and I think it's in nanoseconds, and here it took this amount of time. It's a difference, right? So zero copy deserialization took this time, and look at this. First of all, I checked also archive deserialization, and in this case I did the two operations. The first, I did the archive, so I did this one, and then from the archive I deserialized the object, and the archive copied or cloned this object with all of these fields. So it's kind of not very efficient for using your memory, but yeah, it's just gave you the new copy of your object, and it took longer than using the vscode deserialize. So you can look at that closely one more time. The normal archive, so zero copy deserialization, took 242 nanoseconds, and the archive deserialize, it took 525 nanoseconds for each of this object. And if you think about it, first of all, it's decoded all objects, and then it's deserialized them by creating a new object without the mapping bytes to the real objects. How it works with the zero copy deserialization, when you have the bytes sequence, bytes archive, bytes vector, your archive, I mean the library, using the deserialization, zero copy deserialization, mapped your bytes to the real object and ask your Rust program to work with them like pretending that it's real objects, but actually it's a real object, like a string or something, because it's serialized them exactly how it contains in Rust memory. And But yeah, what the library does, it's trying to be not the platform agnostic. And for the bin code, you can see that bin code deserialization took this amount of time. So it's faster. It's actually faster to do the real deserialization than archive, but to do the zero copy is faster in archive. What I want to do, I want to test it with the memory mapping. And the memory mapping, it's something when you want to do that not faster, but without taking a lot of memory. So you can look exactly on your disk, on your physical device, and map a part of this device to your memory, and then the Rust application can read part of this memory. That's a memory copy, how it works. So you map the one address space to the another address space, and Rust understands how to work with that. I implemented this part even with changing. With the mutable archive, I implemented this with the normal memmap. Let me show it. All of this in a zero copy encoder, zero copy here. So I have a normal memmap here. So it's a normal encoder, and it's serialized the object, use the normal archive deserializer, and then I have here the reader. I already showed that to you. And the new one that I'm working now, this beast, read memmap, and it contains a mutable memmap. So mutable memmap, and here what I'm doing, I'm creating this memmap, and I have the archive, and this archive, I have a very strict clippy. It asks me to create more docs to highlight the errors. I will do that later. Now it's not very important. So, but by now I have this function. This is a normal archive, that's almost a copy, and the most important part, this one, this mutable thing. It asks to provide a function. Here it asks for the function, and function accepts like a parameter, a mutable archive, and inside of this function you can change this archive, and it's pretty much simple. It provides you the really nice interface how you can work with the archive. Let me show you. So it's a zero basics reader. Here we go. Maybe next one. Yeah, here we go. So you see that first of all I created a file. I created a file here. So I created the normal user, and this user contains the user with the name John Doe and amount 256. I don't know what kind of, just a number of something. And then later I create the map. I just created for test purposes. Inside of this map I set the key user and set value, and the value is different at this amount. Let me show. This amount. So it's a different one. So here I creating a new memmap, and this is a mutable memmap, and inside of it I invoke the archive mut, and here you have a user. First of all I use the test map. Yeah, actually what you can do here, you can set whatever you want, any number, but yeah, I use the test map here just to get from the map a number and set this number to the user. And inside of this function you see that immediately right after that I'm doing the memmap flush, and the flush writing the all changes from the memory map to the drive, to the disk. Then you can close the memmap and everything should work fine. But I want to make it more secure, I want to make it more secure. And how I want to do that? Sometimes your disk can fail of writing your bytes, and I want to verify that it's exact amount of bytes that I written. And how can I do that? I can use some checksums, and I can calculate the checksum from the memmap, right? So we have a bytes, we can calculate the checksum and see that everything is written on the disk is the correct amount of bytes. That's what I want to test it. Yeah, for that reason I want to use this library. I think it's a pretty famous library to implement it, and yeah. So let's do that. I need to have a clippy. Oh, sorry, not a clippy. I need to find a cargo. What kind of cargo do I need? Let me think. Yeah, of course. This cargo, where we have the map. Oh, but it's not enough. Sure. Before that, I need to create one more bench test. So let's create one more bench test. What's the name of it? 0 copy. No. The name. Let me think. Deserialization, very long word. Okay. I want to rename this. I don't like the word deserialization. I like the word decoding. It's shorter, right? Decoding. So let's create decoding. I want to copy everything from here. So I want to use similar functionality, the same part here. Maybe I want to use a different naming of it, but in general it should be very similar. Go, but the name of it should be yeah, sure, it should be decoding. So it's decoding. And yeah, remove creation, the temporary file, it's fine, let's write it down. What kind of object do I want to create? I want to create a simple small object, but I want to change many fields of it. And there is a problem, by the way. It's not possible to change the strings because they're kind of literals or something like that, so I can change on the numbers that some the fields that contains the fixed size. So I don't know, let's create a public. I don't need to have a public, just struct user now. But I can do the, I don't know, payment serde. Here I will implement something like number 1, number 2, And the same for archive, right? The same for the archive. We need to change some derive, archive, serialize, archive, deserialize. Then I need to have a flow. And let's implement flow variant one file, of course, files, not zero copy, just file. What the problem? Yeah, sure, for that. The problem. Oh, okay. Archive. Sure. Check. Bytes. Yeah, serde-flow. That's zero copy. Boss should be flow. Now we have two objects. I want to serialize of them and then verify how it's fast to deserializing them. Okay, permanent serde. I don't know. Number 2. Ah, I have a typo. Okay. Where? We need exactly the same object, but for archive. Archive object and serde object. Okay, now we have a serde object and we have an archive object. But I don't have a proper deserialization for the mutable archive. Yeah, it's a lot of work. How I can do that faster? What I can do to implement it faster? Let Let me think. I think I don't need to use this deserialization, so yeah, I don't need to use the flow. I don't need to have it now. To change. Yeah, I don't know. I know that it's not found. Of course, it's not found. Okay, what I need to do now? Bytes. Zero copy encoder. Zero copy encoder. Of course, it's serde-flow encoder. Wow, now what are you doing? Serialize. So we have archive bytes. Then next we have to implement the serde bytes. Change the serde bytes. Encode. What's the problem with that? Serialize. Okay. Encoder, serialize. Do you want to have a flow encoder? Got flow and nah, it's straight. Quarter. Quarter. Ah, yeah, sure. It's a mistake, so it should be here. Now I have a flow encoder, normal flow, zero file, don't have it, zero copy. It's everything from flow. I don't need this from flow, but what I need to store it on the disk. Now we have a bytes. Let's use something sd file system, write all bytes, cave bytes. Pass, let's path. Also need to unwrap it. What? What do you not like it? This. Content goes seconds. Okay, fine. Ah. Insert the path as path. The bytes. Now we have a serde path, serde bytes stored. And what I want to test is deserialize. No, I don't want to deserialize it. I don't care about it, but what I care about it is update. Nah, wait. What I care, the bunch group. Yeah, deserializing? No, serializing. Okay, serializing. That's what I want. Archive map, memory map. We'll do that. Okay. Just thinking about the implementation. I think we need to comment this out. Here we need to implement serial. Just vscode. It's clear. It's clear that we are doing the serialization. It's pretty much clear. What do we need? We need to create a mem map, and we can create a mem map like we're doing it here. Right? Should be here. So I want to create this. Nah. I need to open the decoding here, insert it. P2. Okay. Archive path as path. We open it. Created mutable memory map, and let's think next. Can't find type user because it's not user, it's payment archive by serde. What? Now I'm going to change this payment. So payment. I want to set for both of them, let's say 2. Okay, number 2 also. That would be fine. What? And okay, either mutable reader, complete for you, move it, please. So it should be fine. We're doing that multiple times, using the mem map for that. And here, different thing. We need to read everything in the memory and then deserialize it. So I will copy this part and deserialize it again. Whoa, it's a lot of things we have to do. Here we go. Serialize bytes. What's next? What's next? I need to read bytes first of all. So fs read, then we need to provide the serde path as path. Prop is into here. Payments, sure. We are changing the payment, and it should be the mutable. So deserialize. Please deserialize in what's the name? Payment serde, this object. Okay. Do you really want to have it like this? What? Fine. No, wait. What is your problem, really? So it should be encoding, oh, decoding. Encoding, decoding. Got. So bench encoding. Deserialize. What is the problem? It's defined as implementation for type. What? I'm trying to deserialize serde, not... Yeah, serde, serialize, and deserialize. Ah, okay, got it. No, it's fine. It's completely fine now. Yeah, but it wasn't clear before. Okay, now let's change the payment number 1 to 2 and 2 also. Change the two numbers. Then we need to do that again. Bytes. Serde-flow. Encoder. Pin code. Encoder. Serialize. Payment. Alright. Now I need to write them on a disk. Okay. Spot. Content is our bytes. And that's on. Ooh. Bytes. Oh, they moved. Yeah, sure. But the payment is not moved. I think we can do the black box. Yeah. Please don't use any optimizations. removed. I don't need to do that. Okay. Yeah, sure, I don't need to have it mutable. Should be just fine. And here, yes, I need to have it mutable. Okay. Okay, black box, don't optimize it. And it should be the black box here too. Black box. Fine. Black box. Unused results. Okay, for result, I use unwrap. Okay, and now serde-flow. I have a bench. I have a test suite. Okay, test suite cargo. I don't want to see the prison. I want to see the decoding. Good. Let's run. Running. Benchmark. Serializing archive. Map. Okay. Yeah. And it's clear, and without the mem map, it's much faster. Because you don't need to use your disk. Because when you use a memory map, it literally uses your disk to operate on. Yeah. What I want to test it, I want to verify a checksum when I'm storing something on a disk that it's exactly the thing that I stored. I want to verify I want to verify the overhead that is doing. So it should be relatively simple to do. So for the bin code here, I will implement just a function because I want it just for test purposes. Deserialize check. Yes, deserialize check bytes. Sorry. U8. I want to deserialize it. I want to serialize with check. I want to serialize with check value t, where t should be simple, something that you can serialize. Let's go, and it's return results of fine. I will copy that and I will implement it inside of the benchmarks. Okay, so I really don't need to change it. So I can't open the coding here. I will implement one more function. Serialize check. Exactly, and here I'm going to name it serialize check, but I can name it for serialize check. Serde. Serialize results just something. Serde-flow error, please. It's my type of error. Why did I do that? Okay. Go. Pass import. So I'm gonna verify the overhead that it brings to us. Value. Bytes. Deserialize, not self, but value. Not, but serialize. Now we have a bytes, and then here we go. We need to calculate checksum. Should I use a large one, or the small is more than enough? Let's use this one. I think it should be more than enough. Maybe it's overkill. Let's do this one. Should be insanely small. Insanely small and fast to calculate. So serialize check. Bye. Checksum x95. Checksum. These bytes, yes. These bytes, please. Checksum. Good. Then what I want to do, I want to fs write. Let's write it to. I need to ask for the path. Okay, path. Bytes. Exactly. Unwrap. And the bytes here. I want to read the bytes as the dfs read the bytes, and for that reason, to read the bytes, I use again path unwrap. What else? I need to calculate one more checksum. IO checksum 5 checksum bytes. So if checksum not equal equal checksum, then return error something like, if you're doing that with a serde-flow, and define it. I don't care about that. Import serialize check. Very much fine. And so here we have a vscode, copy, paste, vscode with check. Okay, deserialized, sorry. What is wrong with you? Okay, now it works. Vscode with check. Change it. And I don't need all of this. I need to serialize check. Serde pass as path and payment. payment. Right. Okay. Let me verify that one more time. Panic. I'm writing it down, then I'm reading it one more time and verifying a checksum. Let's bench it. So pure vscode serialization took a 548. Wow, it's so tiny difference between them. This took, yeah, I think it's more secure because we're doing a checksum, we're verifying that the size of the object, not the size, but we're verifying that the bytes are written on the disk, they're exactly the same that I serialized, so it's quite important for us. And it brings us more security, right? Because we're verifying it, and yeah, it's quite important because we can prevent kind of a disk failure. But what we can do if the disk is failed, we can try to write it down one more time, for example. We can return the error. We can try to do something with that. So it's so tiny overhead. You see? Okay. I think that's it. That's what I wanted to test today. And I see that memmap is very slow. It's much slower than have something in your memory, because the drive, even the insanely fast SSD, is much slower and yeah, than your operation memory. So yeah. I would say it's a good result to me. I will continue working on this library. I like it, and yeah, thanks for watching. I think to do that maybe the next time and try maybe something different. Not something different, I still want to work on this library, but if I see some good results from this stream, definitely I will run one more time some of these streams. And I still need to think about the audience, and I don't know how I'm sounding because I'm speaking and yeah, it makes me a bit tired, but it's fine. Okay, thank you very much. See you next time. Don't forget about the Ivan Byte, and if you can follow me on Twitter, or X, the modern name of Twitter, please do that. So thanks for watching. See you next time.